Here I have a 3-node cluster, including a primary and 2 standby databases. The windows I'm using are Node 1, the primary, Node 2 is a standby, which will be promoted during a failover. The other windows I'm using for this demonstration are one for the Node 1 agent logs, and another for my local machine where I can execute Docker commands. For this demonstration, I'm using the new auto rewind property that will be in EFM5.1. This tells the EFM agent to rebuild the primary database as a standby when needed, and it will use PG rewind if that is needed to have the DB follow the new primary. I'm using a 10-second local timeout and node timeout to make failovers happen more quickly for this demonstration. First, I'll cause a failover by stopping the primary database. We can see the connection attempts fail, EFM performs some checks, and the database on node 2 is promoted to become the new primary. On node 1, the agent receives the signal to switch to the new primary. On a standby node, this would tell EFM to reconfigure to follow the new primary. In this case, the agent checks its status and determines that it should rebuild the database node as a standby. It attempts to stop the local database to be safe, retrieves some parameters that may be needed later, and determines whether or not PG rewind is needed based on the wall and the timelines. Then it sets up the database as a standby, starts the database server, and resumes monitoring. We can perform a switchover back to the original primary so that we can follow its logs for the next step. In the next example, I'll use Docker to simulate an overloaded primary node hanging. This is a dangerous situation for any high availability tool because the tool is not running on the primary node until the node resumes working normally again. In this case, node 1 has been paused and is no longer responding to heartbeats or database checks from the rest of the cluster. We can see that node 2 has been promoted to the new primary. I'll unpause node 1. Cases like this take longer to recover than others. First, node 1 doesn't know that there has been a problem until it sees that its last timestamp is too old. It also does not know yet that it has disappeared from the point of view of the rest of the cluster. After a few seconds, all of the nodes rejoin with each other. This involves a conflict between the internal state of the nodes and is resolved. When it's resolved, the agent on node 1 sees that it's been replaced as the primary and fences itself off. Because of the cluster change, a cluster status verification is scheduled. EFM waits before performing this in case there are other cluster changes still happening. When the verification happens, the cluster state is fixed as needed, and each node checks in case it should rebuild. Based on its internal state, the agent on node 1 sees that it should rebuild as a standby. We can perform a switchover again back to node 1. Another failure case can happen if someone reboots the primary server. Normally, this isn't a failover, as a reboot can perform a proper shutdown of the agent and database. With the primary shutdown as failure property set to true, the rest of the cluster will treat the primary agent shutdown as a failure, test the primary database, and failover as needed. I have it set for this demonstration, and we can test this case easily with a proper shutdown of the services on node 1. The rest of the cluster promotes quickly in this case because there is no timeout associated with a proper shutdown. Now when we restart the original primary agent, it will connect to the rest of the cluster. The node 1 agent sees that there is already a primary database in the cluster, and it sees that node 1 is not configured to be a standby. So it knows that this used to be a primary, and it will also rebuild itself because it's been replaced by another one.